Hello everyone, I am Dr. Muzammil Liaquat Ali, and in this lecture, we will discuss chlorine, an essential electrolyte that works closely with sodium to maintain fluid balance and acid-base equilibrium. Chlorine is a constituent of sodium chloride, a common salt. Hence, the metabolism of chlorine and sodium are intimately related. Changes in sodium balance are almost always accompanied by parallel changes in chloride balance. The sources, the sources of chlorine are essential as the same as those for sodium. Common salt as cooking medium, whole grains, leafy vegetables, eggs, and milk. Adequate intake of sodium chloride or common salt typically satisfies both sodium and chloride requirements. Let's discuss the absorption and plasma levels of chlorine or chloride. Chloride is almost totally absorbed in the gastrointestinal tract, similar to sodium. Plasma chloride levels normally is about 96 to 105 milliequivalents per liter. When chloride levels fall below normal, it is called as hypochloremia. When the levels rise above that, the value is 105 milliequivalents per liter, that is called hyperchloremia. Excretion of chloride or chlorine, there exists a parallel relationship between excretion of chloride and sodium. When sodium is retained, chlorine or chloride is also retained. When sodium is excreted, chloride is also excreted. The renal threshold for chloride is about 110 milliequivalents per liter. When plasma chloride exceeds this level, the kidneys begin to excrete the excess into the urine. Let's discuss the biochemical function of chlorine. Chlorine provides several important biochemical functions. Very first one is it helps regulate acid-base balance, fluid balance, and osmotic pressure. Chloride is the major anion in extracellular fluid, balancing the positive charge of sodium. Second, it is essential for the formation of hydrochloric acid in gastric juice. The parietal cells of the stomach produce HCl, which is necessary for protein digestion and for killing ingested bacteria. Next is the chloride shift. Chloride shift, also known as Hamburger shift. This is a process that occurs in red blood cells involving the exchange of bicarbonate and chloride across the red blood cell membrane. This mechanism is crucial for the transport of carbon dioxide from tissues to the lungs. And finally, chlorine plays a role in activation of salivary amylase, the enzyme that begins the starch digestion in the mouth. Let us now discuss diseases or disease states associated with abnormal chlorine levels. The very first one is the hyperchloremia, or increased chloride levels that occur due to either dehydration, respiratory acidosis, where the kidneys compensate by retaining chloride. And finally, Cushing syndrome, where excess cortisol leads to sodium and chloride retention. The second one is the hypochloremia, or the decreased chloride levels that occur due to either vomiting, diarrhea, respiratory alkalosis, where the kidneys excrete more chloride to compensate, and the Addison disease, where aldosterone deficiency leads to sodium and chloride loss. And excess sweating also leads to hypochloremia. Let's discuss the dietary requirements. The daily requirement of sodium chloride is approximately 5 to 10 grams. Adequate intake of common salt will satisfy the chloride requirements of the body. However, it is important to note that the balance of the salt intake and excessive consumption can contribute to hypertension or other cardiovascular tissues or issues. Finally, to summarize our discussion on chlorine, let's chalk out its final points. Chlorine is the constituent of sodium chloride, and its metabolism is closely linked to sodium. Normal plasma chloride is 96 to 105 millicoulombs per liter. It is involved in acid-base balance, gastric acid formation, the chloride shift, and salivary amylase activation. Hyperchloremia occurs in dehydration, respiratory acidosis, and Cushing syndrome, while the hypochloremia occurs in vomiting, diarrhea, respiratory alkalosis, and Addison disease. Finally, the daily requirement is met through 5 to 10 grams of the common salt. Thank you very much for the listening. And in our next lecture, we will discuss the potassium. Thank you once again.